All right, good morning and welcome to Master Talker online class. In today's video, we'll be talking about linear expansivity. Right? If today is your first day of watching our video, please click the subscribe button. Okay? So now let's talk about linear expansivity. Linear expansivity is defined as what? Uh, the change in length per unit change in temperature. Very simple. Or you call it increase in length per unit increase in temperature. Very simple. And then note that linear expansivity is equally called, you can call it coefficient of linear expansivity. Sometimes they call it coefficient of linear expansivity or just linear expansivity. It is what? Increase in length per unit increase in temperature. And don't forget that your temperature must be in Kelvin, because linear expansivity is measured in Kelvin. We represent it with this, measured in Kelvin. Okay, per Kelvin, sorry, per Kelvin, not just Kelvin, per Kelvin, because the Kelvin is down, per Kelvin. Okay, so we have that what? Linear expansivity. Now we have three types of expansivity. We have linear expansivity, area expansivity, and cubic expansivity. We are talking about linear expansivity. So we have it as what? Increase in length per unit length, that is over original length, then times what? Increase in temperature. Okay, so linear expansivity will represent it with what? Alpha is equal to what? Change in length over what? Original length, then times change in what? Temperature. Right? So that length cancel length is in meter, cancel meter, and what is left is Kelvin. So that is why it is measured in what? In per Kelvin. It's measured in per Kelvin. So if you break this down, you have that what? Linear expansivity is what? Change in length means the preceding length minus the original length all over what? Or the new length minus the original length all over the new the original length, then times what? The new temperature minus the original temperature. Okay, so now let us assume that that theta 1 minus theta 0 is equal to what? Just theta. So we have that what? Alpha is equal to what? L1 minus L0 all over. This formula is very, very important. So minus L0 all over what? L0 theta. Okay, if I cross multiply, I'll be having that what? L1 minus L0 is equal to what? Alpha theta L0. Let me write it like this. So this one moving here, I'll have that what? L1 is equal to what? L0 minus what? Alpha theta L0. Okay, so permit me to finish it up here. I'll be having that what? I want to get the new length. The new length L1 will now be what? If you decide to factorize, you have what? L0 in bracket of 1 minus what? Alpha theta. So this is the formula to get the new length. Okay? This is the formula to get your new length. All right? Then, but the thing is that you don't need to know this formula. You don't need to remember this formula. Once you know this one, you can get anything you are looking for. Once you know this one, you can get anything you are looking for. So let us solve some calculations to illustrate that. So the first question we're going to solve said, number one said a metal rod of length 40 cm at 20 degrees Celsius is heated through a temperature of 45 degrees Celsius. Then I say if the new length of the rod is 40.05 cm, then I say calculate the linear expansivity. Calculate the linear expansivity of the rod. Okay. Solution. Now this is a very simple question now. So what do? Let us bring out our parameters. The first thing they gave us is the original length. The original length there is what? 40 cm. and the original temperature there is what? 20 cm, so 20 degrees Celsius. So convert to Kelvin immediately because the SI unit of linear expansivity is in Kelvin. So I have that what? 20 plus 273, which will give you what? 20 plus 273. 20 plus 273. 293. So I have 293 Kelvin. So the next thing they gave me is the new length is what? 40.00 cm. The new temperature is what? 45 degrees Celsius, which is what? 45 plus 273, which will give you what? 45 plus 273. So I have 318 Kelvin. So I know my formula that says that linear expansivity is what? Change in length over original length, then change in temperature. So what do I have? L1 minus L0 all over what? L0. Then in bracket of theta 1 minus theta 0. Sorry. Please note that some people use L1, L2, and L1, where L1 is their own original length. So please don't be confused. Okay? If your own textbook is using L2 minus L1, or maybe your lecturer is using L2 minus L1, use the same L2 minus L1. It's the same thing. So if you're using L2 minus, and you have L2 minus L1 all over that same L1, then in bracket of theta 2 minus theta 1 is the same thing. It's the same thing. So it depends on what the person wants to use. Okay. So me, I like using L1 and L0. So my linear expansivity will now be my L1 is 40.05. Sorry, 0.05. 40.05 minus 40 itself all over that same 40 in bracket of what? 318 minus 293. So what do we have? 0.05 all over 40 in bracket of minus 293, 25. So what do I have? 0.05 divided by times 40 divided by 1000. So what do I have? 0. So I have 0.05 divided by my last answer. So I have 24. 1, 2, 3, 4, 5 per Kelvin. Or you say what? 5 times 10 raised power 1, 2, 3, 4, 5 times 10 raised power minus 5 per Kelvin. Per Kelvin. Okay? So the next question, question number 2. Please don't always forget that your temperature must be in Kelvin. Question number 2 said an iron rod of length 20 cm is heated through 60 Kelvin. Calculate its increase in length. Calculate its increase in length. Then I say the linear expansivity of the rod. The linear expansivity of the rod is 1.2 times 10 raised power minus 5 per Kelvin. Okay? Solution. So what do we do? What do we do? The first thing we do is to get the original length. The original length of this thing is 20 cm. Okay? Then we are looking for the change in length. The change in length. We're not looking for the new length. They say we should get the change in length. Okay? So we are not looking for the new length. What we are looking for is the change in length. The change in length is what we're looking for, and not the new length. So you have to be very, very. They say calculate the increase in length. Increase in length is something as change in length. Okay, they're not asking you the new length. So I know my formula that said that what alpha linear expansivity is what? Increase in length over original length, then increase in temperature. Increase in temperature. Increase in temperature. Increase in temperature. That is theta. Let's just use theta. So my theta they gave me here is just 60 Kelvin. Okay, so I know that my change in length will now be what? Alpha theta L0, which is what? 1.2 times 10 raised power minus 5 times 60, then times what? 20. So if you multiply everything out, you'll be having 0.044 cm. So this is the increase in temperature. Then, but if they are asking you the new length, you tell them that what? Increase in length is equal to what? L2, sorry. Okay, let's use L1 minus L0. Okay, so this one they've given me 0.0144 is equal to what? My L1 is what I'm looking for, minus what? 20. So collect like terms to have that your L1 will now be what? 20 plus that 0.0144, okay, which will give you what? 20.0144 cm. Okay, so this is the new length, but that is what they are, what that is not what they are asking us. The only thing they are asking us is what? That we should calculate the what? The increase in length. So know the difference, please. Know the difference. So the next thing we are being asked to find is question number 3. Question number 3 said, what is meant by the statement? What is meant by the statement? The linear, sorry, the linear expansivity, the linear expansivity of a solid is 1.0 times 10 raised power minus 5 per Kelvin. Okay. Then the B part of the question, this is A. The B part of the question said steel rod, okay, steel bar each of length, steel bars each of length 3 meter at 29 degrees Celsius are to be used for construction, for constructing a rail line. And I say if the linear expansivity, of the steel is 1.0 times 10 raised power minus 5 per Kelvin, then I say calculate the safety gap that must be left between successive bars if the highest temperature expected is 41 degrees Celsius. Okay, so the first one said, what is meant by the statement the linear expansivity of a solid is 1.0 times 10 raised to power minus 5. Right, you tell them that what? That the linear expansivity of a solid is 1.0 times 10 raised to power minus 5 means that the increase in length per unit rise in temperature when the solid is heated will be equal to that number. Okay, just follow the way you define linear expansivity to do what? To say the answer. Okay, you tell them that what? That the increase in length per unit rise in temperature, or per unit increase in temperature of the solid is equal to what? 1.0 when is equal to 1.0 when heated. Okay, so solution. So I've gotten the solution of the first one. Then for the second one, they say we should calculate what? The gap is simply means the increase, that is the change in the length. Okay, the change in the length is the gap. So what did they give us now? They gave us, the first thing they gave us is okay, that the original length is 3 meters. Okay, and they gave us the first temperature. They gave us theta naught is what? 29 degrees Celsius. They gave us theta 1 as what? 41 degrees Celsius. All right. So theta, which is then as what? Theta 1 minus theta 0 will now be what? 41 minus 29. So what do you have? You have 12 degrees Celsius. Okay. So I now know that what? Let me complete it here. I now know that my linear expansivity is what? Change in length all over what? Original length, then change in temperature, theta. So I'm looking for the change in length. So my change in length will now be what? Alpha L0 theta, which is what? My alpha there, linear expansivity is 1.0 times 10 raised power minus 5 times my original length is 3, then times my rise in temperature is 12. So if you calculate everything, you will be having that the change in temperature is 3.6 times 10 raised power minus 4 meter. So the gap that should be given in between the bars is the change in temperature, which is what? 3.6 times 10 raised power minus 4. Okay, in meters, right? So why? Because the other one was in meter. So that's why you leave your answer in the same unit. Okay, so question number 4 said a wire 20 cm long is heated from a temperature of 5 degrees Celsius to 55 degrees Celsius. Then I say if the change if the change in length is 0.020 cm, calculate the linear expansivity. The linear expansivity. So solution. So the first thing they gave me is the original length, which is what? 20 cm. The next thing they gave me is change in the length, which is what? 0.020 cm. Okay, so the next thing they gave me now is what? Theta 0 is what? 5 degrees Celsius, and theta 1 is equal to what? 55 degrees Celsius. So my theta normally should be theta 1 minus theta 0, which is what? 55 minus 5, which is what? 50 degrees Celsius. So I know that my linear expansivity is what? Change in length all over original length, then change in temperature. So which is what? Change in length they gave me already as 0.020 divided by 20 times this one 50. So 0.020 all over what? 1,1000. So what do you have? If you divide that, you will now be having you'll be having 0 point, how many zeros? 4. 1 2 3 4 2 per Kelvin. So which is what? 2.0 times 10 raised power minus 5 per Kelvin. Okay, so we're going to solve the last question here before we enter area expansivity. So the last question we're going to solve, question number 5 for this, said that a rod of length 50 meters and a temperature of 60 degrees Celsius is heated to 70 degrees Celsius. Then they now say calculate its new length. Calculate its new length. All right. They now give you that the linear expansivity of the rod, okay, is equal to 1.2 times 10 raised to power minus 5 per Kelvin. Okay, per Kelvin. All right, so solution. This is a very simple question. So the first thing they gave me, in fact, I told that you don't need to know any other formula apart from your normal formula that you know. Okay, so they gave me our theta 1, sorry, theta naught as 60 degrees Celsius, our theta 1 as what, 70 degrees Celsius. So our normal theta will now be theta 1 minus theta 0, which is what, 70 minus 60, which is what, 10 degrees Celsius. Okay, so the next thing they gave me is the original length. The original length is 50 meters, and they gave me that my linear expansivity is 1.2 times 10 raised to power minus 5 per Kelvin. So, but I know that my normal distance linear expansivity is what? Change in length over what? Original length, then change in temperature. So, first of all, let us get what change in length is. Our change in length, will now be what? Alpha L0 theta, which is what? My alpha 1.2 times 10 raised to power minus 5 times my L0. My L0 is 50, then times my theta itself, theta which is what, 10. If you multiply this out, you'll be having 0 sorry 1.2 times 10 raised to power 1.2 times 10 raised to power minus 5. Okay, then times 50 times 10. So I have 0.06 meters. So this is the change in temperature, and sorry, the change in the length. But I know that change in length is something as saying original the new length minus the original length. Okay, so if you now put this one, you now have 0.006 is equal to what? The original length they gave me was 50 minus L, sorry, the new length I'm looking for minus 50. So this one will now move here to have 0.006 plus 50 is equal to the new length I'm looking for. So the new length will now be what? 50.006 in meters. Very, very simple. So the next thing we'll talk about is what? Area expansivity. Area expansivity. Okay? All right. Area expansivity. Area expansivity. Right? Now, area expansivity. Now, area expansivity is defined the same way you define linear expansivity. But in linear expansivity, what we are using is length, length, length. But in area expansivity, we'll now be using area, area, area. So remember that linear expansivity is defined as what? Increase in length per unit length per unit increase in temperature. So here, what do you define it as what? Increase in area per unit increase in temperature. Very simple. Okay, so we have that what? Area expansivity. We represent this one as beta. The other one is alpha, beta, then the last one is now gamma. Okay, so I have area expansivity which is represented with what? Beta. Okay, is equal to what? Increase in area over what? The original area times then increase in temperature. Okay, so what do we have? Beta is equal to what? Area, change in area over what? The original area, then times what? The change in temperature. That is the change in temperature. Or you just call it theta. Let just theta be the change in temperature. All right, so we know that what? That beta will now be what? Change in area is what? The new one minus what? The original one, all over what? That original one times what? You know that this one means the new one minus the original one. So that is that. It's a very, very simple formula to remember. So where you know that what that A1 is what the new area, the new area. A0 is what the original area, original area. Okay, then what a sorry L theta 1 is what the new temperature. That new temperature must be in Kelvin. So this is what the original original temperature, and it must be in Kelvin. So this one, area expansivity is equally measured in per Kelvin. Area expansivity is equally measured in what? In per Kelvin. Now, another very important thing you need to know is that what? That area expansivity is equal to what? 2 times linear expansivity. Okay? Area expansivity is equal to what? 2 times linear expansivity. Very important formula. Area expansivity. Area expansivity is equal to what? 2 times linear expansivity. So area expansivity is beta is equal to what? 2 times alpha. So beta is equal to what? 2 alpha. Very, very important formula. Very important. That area expansivity is equal to what? 2 times linear expansivity. So let us solve some calculations to illustrate what we have just done. Okay? The first question. The first question said the cross-sectional area of a metal, the cross-sectional of a metallic rod is 4 meters squared when the temperature is 2 degrees Celsius and 6.8 meters squared at 25 degrees Celsius. Then I say calculate the coefficient of the superphysic expansivity. Okay, now please note that what area expansivity is equally known as what? The coefficient of what? Superficial. Okay, superficial, sorry, the what? The coefficient of superficial expansivity. And then don't forget that linear expansivity is known as what? The coefficient of linear expansivity. I told you is equally called coefficient of linear expansivity, but this one is called the coefficient of superficial expansion. Coefficient of superficial expansion. So they say calculate I the coefficient of the superficial expansion. Okay, they say calculate the coefficient of linear expansion. Solution. Okay, these are the two things they asked me to calculate. So, but first of all, I know that the first area, which is the original area they gave me, is 4 meters square. Okay, they gave me the second area, which is what? 6.8 meters square. So my change in area should be equal to what? A2 or A1 minus A0. Okay, some people use 2 and 1, like I said before. So which is what? 6.8 minus 4, which is what? 2.8 meters squared. So they gave me theta naught, the original temperature, which is 2 degrees Celsius. So but the new temperature they gave me was what? 25 degrees Celsius. So my change in temperature theta, which is equal to what? Theta 1 minus theta 0. Okay, which is what? 25 minus 2, which is what? 23 degrees Celsius. So I know that my area expansivity beta is equal to what? Change in area over that original area, then change in temperature. Very simple. So let me now put it. Change in area, I have gotten it as 2.8 all over change in original area, which is what? 4 times the change in temperature is what? 23. So you will now have 2.8 2.8 divided by 4 divided by 23. So I have what? 3.04 times 10 raised to power minus 2. So that is my area per Kelvin, area expansivity. So which is helping as saying what? 0.0301412 per Kelvin. So now I have gotten my area expansivity, but they say we should equally get our linear expansivity. Okay, they say we should equally get our linear expansivity. But I will tell them that what? That area expansivity is equal to what? 2 times linear expansivity. So to get my linear expansivity will now be what? Area expansivity divided by 2, which is what? 0.0304 divided by 2. So if you now divide it by 2, you'll be having divided by 2, which is 1.5 times 1.52 times 10 raised to power minus 2, which is what? 0.052. Okay, 0.0152, sorry, 0.0152. Okay, so per Kelvin, please don't forget, per Kelvin. So question number 2. See, this topic is the simplest in physics. This is the simplest topic in physics. So the second question here said a metal, number 2 said a metal plate has a surface area of 1.23 meters squared at minus 10 degrees Celsius. Was the other one in Kelvin? What? That's a very bad mistake. The temperature must be in per Kelvin. So that calculation is wrong. So do your own calculation and put your temperature in Kelvin, please. This calculation is very, unless maybe we are going to leave it in degrees Celsius, per degree Celsius, but the SI unit is per Kelvin. Please leave your answer in per Kelvin. Please leave your temperature in Kelvin, please. That's a very bad mistake. Okay, so I have degree Celsius. Then what will okay, they're taking the light, so bye bye.